Good afternoon. Hope all of you are doing great and enjoyed your small fall break. I know I took some time off, which is why your test 2 will be graded by tomorrow night. So I needed to take some time off. I was getting chronically tired, like I wasn't getting enough rest, as I'm sure most of you can relate. And so I'm caught up on my rest and I feel a lot better. So I will have those test 2s graded by tomorrow night. I've already graded my 2 online anytime classes, and so I know what I'm in store for. So you'll have those. I will have those done by tomorrow night, and I'll let you know. I will let you know where to go to find what, how to go into Canvas to review your written work, and how to go into ALEKS to see your final score, and also how to review your test question by question. So let's get started. I can't think of any other announcements that I have right now. So what we are going to be talking about today are exponential functions, which reminded me of another announcement I wanted to make. I did not intend for that objective to be due so quickly. I intended it for it to be due this Sunday, so I extended the due date to this Sunday. So I thank you all for who completed that objective already for doing so by the due date, but I feel like I didn't do my due diligence with presenting that particular objective yet, so I extended the due date to this Sunday. If you are caught up with your objective, let's say you've already completed the objective that's due on Sunday, you can go back and work on past due objectives in ALEKS that you have not, for which you have not completed all the topics. So if you choose to do that, you can only do that until the next objective opens up. And that would be on Sunday night, basically. So you can only do that until Sunday night, only if you have the current objective completed. You can go back and work on past due objectives. Unfortunately, ALEKS doesn't automatically update your score. So in order to get credit for that, you will need to go into assignments on the main menu and send me a screenshot of your current score on that particular objective for which you want to get credit for. So that's the way we can handle that. I think it's a very, very good idea that ALEKS just implemented, but I wish and have already requested that they give students credit for doing those past due topics. So let's get started. We are going to talk about exponential functions today. Exponential functions have a variable in the exponent, hence the word exponential in a sense. They have the variable in the exponent. So let's get started here. To get started, I want to spend some time on doing topics in ALEKS today. We have a few graphing objectives coming up before the end of the course, and you'll see me spend more time in ALEKS for those particular objectives. So let's get started. I will go into ALEKS now. And I'm sharing my screen, so that shouldn't be a problem. Let me get out of here. Let's go into ALEKS. I've got to get out of here. Okay, so I'm going to open up a new ALEKS session. I did something a little different with my students in the previous class, and I'm probably going to do that with y'all too. So we'll talk about that towards the end of class. So I'm going to go to ALEKS. I'm going to click on my name, click on the class I want. And I'm going to select this one. And then I'm going to go on into Alex, the student view. Oopsie. I think I didn't select the right one. Let me reselect that. I saw the 8 in it and I didn't check for the zeros. Now I've got what I want. Skip the tool tips for sure. And let's go on into Alex. So I'm in review mode and I can go, you can also go to review mode if you've already learned topics, and you can go find the objective for which you want to review some topics and go from there. So I am going to click on this review and then go down to, getting a little ahead of myself, exponential functions is what we want. So that's what we want to work on today. I would love if all of you had your graphing calculators available or could quickly grab them. We're going to spend a lot of time talking about the graphing calculator today. It is a very handy device. So to get started, let's start with something that is, I think we can all relate to. Let's look at translating a graph of an exponential function. So let's look at this function. Below is the graph of y equals 1/4 raised to the x. An exponential function has a variable in the exponent. So we're seeing that x in the exponent. So below is the graph of y equals 1/4 raised to the x. Translate. Translate means to move the graph right, left, up, or down. Translate it to become the graph of y equals 1/4 x plus 1, and that's raised to the x plus 1, plus 3. So we want to make sure we're abiding by the rules of PEMDAS. Parentheses come first. So we're trying to decide what to do here. Parentheses come first, but we can't just really do anything with just the 1/4. The E in PEMDAS is exponent. So we want to do this translation first. Now, what do we do if we want to take the graph of our original function, which we have right here, already graphed for us, and translate it to become this function? What do we do to the old graph to get this new graph? Which direction do we go? Do we go left, right, up, or down, and by how much? So do we go left 1, right 1, up 1, or down 1? What do we do? Can anybody tell me? So remember this 1, adding 1 is next door to the x. How does that work? Which direction that does being next door to the x go? Does it go left, right, up, or down? So back when we did transformations before, which way did we go when we had a number being added next door to the x, or a number being?
It goes left.
It goes left because a number being, that's correct, because a number added or subtracted next door to the x works opposite of what we would think. So even though we're adding, we don't go right, we actually go left. So we're going to go left 1 unit because of this 1. So I'm going to take this dot right here at this point at 0, 1 that Alex has labeled, and I'm going to move it left 1 unit, and I'm going to do it very carefully and stop. I'm not going to attempt to try to do both at the same time. And then this plus 3 is being added down the street. It's not next door to the x. It works like we would think, so we want to go up 3. So currently we are at a y of 1. We want to go, if we take 1 and add 3 to it, we're going to get 4. So we want to go up to 4 here and make sure we stay correct. Now we wanted to move 1 in this direction. So I'm trying to make sure that I did that. And we are now up at 4. Now what I would encourage you all to do is to check. Get the coordinates of this blue point up here. So if I go straight down to the x-axis, we've got -1. And then we want to go straight over to the y-axis, and that's at 4. So that point that we're talking about, that blue point, is at -1, 4. So what we want to ask ourselves is, does that ordered pair, -1, 4, satisfy this equation right here? So that's how you can get your bars or your bubbles, whatever you want to call them, filled in quicker. And it's just a quick check. So what I want to do is I want to look at this side, 1/4 raised to the x. We think x is -1. -1 plus 1 is 0. So if you put 1/4 in your calculator, put 1/4 in your calculator now, put parentheses, 1 divided by 4, just like you see it. And then this mountain peak here, this mountain peak, which means you can raise to any power you want. This mountain peak in the rightmost column of the calculator. It's like a mountain peak. So if you click on that, so I'm going to do that. And then I can put anything in the exponent I want. Now I think that the x is -1 of my order, and of my ordered pair, my x is in that ordered pair, x is -1. So I'm going to put -1 in and -1 in the bottom row of the calculator. The negative sign is right here in the bottom row of this calculator. And you will see me use the calculator more and more as we go through the course now. So it's important to bring it to class. So then after I put in -1 for x, we need to put in +1 here. Right arrow out of the exponent. So a right arrow is right here. These are the arrow keys here. Right arrow that way. And then that'll get me back to the normal line of writing. And then we have to add on that 3 at the very end and enter. And I got 4. Well, 4 happens to be my y coordinates, so I'm good. I know I've got this problem right. I've got it in the bag. So I check, and there you go. So those quick checks are so helpful because they'll help you get your topics done quicker. So anytime you can do a quick check like that, I highly recommend it. Any questions on this particular problem? Good way to review translating the graphs of functions too. Let me check that off our list. Let's look at finding domain and range from the graph of an exponential function. Remember, domain is a set of all x coordinates and range is a set of all y coordinates. D comes before R's in the alphabet. X comes before Y in the alphabet. That's how I know domain is the X's and range is the Y's. So let's go grab that topic, find that topic in the carousel. So finding the domain and range of the graph from an exponential function. Let's take a look at this one. We'll look at a couple of these. You will notice that the number of topics in each objective is starting to get smaller. I'm not going to say that every objective, if from now until the end of the class, that is the end of the semester, has less topics. But you will notice that there are a number of the objectives that have fewer topics than we're used to now. And that's because we're getting into objectives which are less and less review for you. So I'm trying to talk about fewer topics because of that. So let's see what we need to do here. The graph of an exponential function is shown in the figure below. So this is the graph of an exponential function. They have this characteristic shape where they go down really fast and then taper off, or they go up really fast and then, or they go up really fast towards the end. So they start out slowly at the beginning, I will say, and some of like this start out slowly at the beginning and then shoot up really fast. We see that in population growth, and right now, being in a pandemic, we hear about exponential growth in the news sometimes. At least I do when I listen to the news, and so and I will point this out likely when we see a graph that's more consistent with population growth. This one's lying beneath the x-axis here, and this would be more like radioactive decay if it lied above the x-axis. So I will point that out more as we go along. Anyway, we've got this graph of an exponential function. They have this characteristic shape where they go down really fast and then level off, or go up really slowly and then at the end shoot up really fast. So they have that characteristic shape. The horizontal asymptote is shown as a dashed line. So this dashed line is what we call an asymptote. It is not part of the graph. This is the graph. The horizontal line is not, this horizontal dashed line is not part of that graph. You could think of it as more as a guide, or that our graph approaches that horizontal line, doesn't cross it, and doesn't intersect that horizontal line. It may look like it's going to, but it doesn't. It just goes down slowly that it does not ever intersect the horizontal asymptote. We want to find the domain and range of the graph. Now, domain is the set of all x's. How do we get all the x's? We can collect all the x's on the x-axis. So this goes in this direction forever and ever. So we can collect all these guys on the x-axis. So we go to points on our graph to get their x coordinates. We just go to the x-axis and collect them all. So I'm collecting all these points, and then I go up here, collect all the x's of all these points on our graph, and I keep going and going and going and going. This arrow goes on forever, so I'm going to be going. I'm going to trace all of these up here to the x-axis forever and ever and ever and ever. So my domain, our domain is all real numbers. So I'm going to click in here, and Alex has all reals has an option down here. So I'm going to click on all reals, and that will automatically put the terms all and reals in for the domain. Now the range is a different story. So the range is all the y's. So we're starting down here at negative infinity on the y-axis, and we're looking for points on our graph, and we don't see any points on our graph until we're a hair above this right here. So this is -6, this is -4. You might not be able to read the graph. Let me see if I can get this up a little bigger so you can read the graph. So we're coming up here from negative infinity, and we're looking for, we're wanting to trace every point on our graph really back to the y-axis. And we don't see anything down here. There's no part of our graph here, so we can ignore that. The first spot that we see a point on our graph that we could trace over to the y-axis is out here. If we trace that over to the y-axis, it's just a hair above this -4. It's just a hair above that -4. So -4 is definitely going to come into play. And then how can we collect more points on the y-axis? We just pick points here, trace them over to the y-axis, pick a point here, trace it over to the y-axis. This point is there because it's on the y-axis. Trace points from over here to the y-axis. Keep doing it forever and ever the rest of our life. And what we see is the lowest point under consideration is -4, and the highest one is infinity. However, Alex doesn't quite do it like that, but we could look at it as -4 is less than all the y's. You could look at it as -4 is less than all the y's. That's how we can state the range. We're talking about the y-axis here. So we need -4 is less than all the y's. So how do we put that in Alex? So we want a number less than another. We want -4 less than less than 1. So we want to select this one. I believe all you're going to use is this one, and all reals for this particular topic. Click in the range box, click on this one, and we want -4 right here. -4 less than all the y's. So -4 is this isn't one of the y isn't in the range, but we're looking at y's that are ever so close to -4. That's the reason for the less than. That horizontal asymptote is not part of the graph. The graph never intersects it or touches that horizontal dashed line. So I'm just going to type in a y here and check. So we got it correct. So we want all the y's starting at -4, not including -4, and all the y's that are bigger than -4. That's what we want. We want all the y's read from this way. Y's, all y's bigger than, the open mouth means bigger. Well, all y's bigger than -4. That's a good way to check it by looking at the graph. Any questions on this particular question from this particular topic? I'm tempted to do another one. So let's take a look at another one. Do you have anybody have a question? That's fine. If you do, you feel free to interrupt. Look at more practice. And let's take a look at this one. Because now the horizontal dashed line lies above it. And by the way, even though it looks like this graph intersects the horizontal dashed line, it does not. Assume it does not. So the graph of an exponential function is shown in the figure below. The horizontal asymptote is shown as a dashed line. Find the domain and range. Well, the domain is pretty simple. We just want to collect all the x's. So this goes out a little bit, over and out a little bit all the time. It's just very tiny that it does it, but it has forever to do it. So this will reach and get closer and closer to infinity all the time. The x's will get closer and closer to infinity all the time. So we want to trace our graph up to the x-axis. This goes over and out. So it's going to actually be when we come in from negative infinity here, or if we were to trace all of these, the x coordinates of all these points that go over and out forever, we would be tracing them all back up here. So we would collect all of those, and then we would trace these up to the x-axis, all of these up to the x-axis, and so forth. So we would get all real numbers again. That's characteristic of exponential functions. the domain is all real numbers. So this domain right here is all reals. Now the range is different. So we're coming up, we want the set of all y's. This is going to go down forever. So when we start at negative infinity and we're taking all of these and moving them up and tracing them over to the y-axis this time, we're going to get all of these. And then we trace over to the y-axis this direction. We're going to get all of those. And this, and so forth. We're going to get all the numbers up to this horizontal asymptote, not including that horizontal asymptote, which is at -1. So let's select this first. And let me make sure I put the cursor in the box and select this. So this time we want to start out with all these y's down here because we collected all these y's all the way down here. Because this is going down, 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 down. So this time we want to make sure we're putting y in this box. And we want it to be less than this right here, where this horizontal asymptote is, because the horizontal asymptote is not part of the graph, and that horizontal asymptote is at -1. That's why we don't want less than or equal to, because the horizontal asymptote is not part of the graph. So that horizontal asymptote is at -1. Now just to check, this says we want all the y's that are less than -1. So we want all these y's that are less than -1. That's correct, because we can trace we can trace every point on this graph back over to the y-axis. So let's check. Any questions on finding the domain and range from the graph of an exponential function? So now let's talk about graphing. And where we're going to make t-tables. Let's look at graphing an exponential function in the form f of x equals b to the x. And that's a times b to the x. We're not quite ready to do that. Let's see, here we go. I'm not sure. Let me take a look at this table for an exponential function, because I really want to talk to you about how you can use the graphing calculator to help you out. So let's look at this topic. So we have a basic exponential function here, which is h of x equals 6 raised to the variable x. That's as basic as you can get for an exponential function. You've got to have a base, and our base is 6. That's the bottom of the exponent. And then you have to have the minimum that you can have in the exponent is an x. So we want to fill this out. We want to fill out this t-table here. That's what we want to do. So how do we do that? So what I would like you all to do, and let me just get this so we can all see it, is copy down that t-table. So I'm going to copy that down too. And then we're going to work with our graphing calculator so you can see how to do this problem. And then we're going to do a couple of other graphing problems too. They get more complicated. So I'm going to write down the t-table. I'm just going to put in -2, -1, and this is typically what we use, 0, 1, 2. So -2, -1, 0, 1, and 2. And h of x equals 6 raised to the x. So I'm going to go down. I'll give you a moment, and then we'll go down, and I figured out I could use Microsoft Word as a whiteboard. I don't like the whiteboard that's in Teams. So let's go down and work on this t-table. So what we have here, I'm going to make this t-table here. This is our X column. This is our H of X column. And H of X is equal to the number 6, base 6, raised to the X. So we want to fill that out. So before we get started with this, I had a little time left over in my last class, and I encouraged the students to get into ALEKS and ask me some questions. Well, I had one student that asked me about the calculator. How do I convert to a fraction on the calculator? So what I want you all to do is go to the home screen on the calculator and clear off what's there. So you can use this clear button here to clean up your home screen if it gets too cluttered. I'm going to clear what's off of my home screen by clicking on that clear button right here. Now what I would like you to do is just type in 0.25 on your home screen. 0.25. So the point here is down here. This decimal point is right there, 2.25. So you're going up these 3 keys here. 0.25. And then what we want to do, and this is where what's really helpful, is we want to convert to a fraction. And how do we convert to a fraction? What we do is we use these keys. The math key, it's in the first column, M, A, T, H. Followed by the enter key twice. So here's the enter key right down here, bottom right of the calculator, enter. So followed by the enter key 2 times. So that would be E, N, T, E, R twice. I'm going to do that twice. Twice. Two times. That's what you want to do. So if you do that when you have 0.25, what do you get? Can anyone tell me what you get when you do math, enter, enter? What do you get? So please enter 0.25 on your home screen, and then hit the math key, and then hit enter twice. Enter, enter. So it's math, enter, enter. Can somebody tell me what they got?
Don't you just get a fraction?
Yes, yes. So this is showing you how to convert to a fraction. So what fraction did you get? So I want to make sure that all students understand how to use their graphing calculators to change decimals into fractions, because ALEKS requires exact answers without rounding. Anybody get an answer for 0.25? What fraction is that? What fraction is that? You are welcome to go grab your graphing calculators, because we're going to use them.
Is it 1/4?
It is 1/4. Yes, congratulations. It is 1/4. Great. Yep, that turns out to be 1/4. So you might want to write that down just to make sure you understand how to basically convert from a decimal to a fraction. As we go throughout this course, we're going to see more graphing topics after after today. We're going to see quite a few graphing topics before the end of the course, and it'll be very important that you know how to create t-tables and how to get the x and the y, or you could say the input and the output exactly, because Alex will not let you round it. They'll tell you it's incorrect. So let's fill out this t-table, keeping in mind how we convert to fractions. So I will fill this out. Let's start with -2. And one thing you want to keep in mind, in Alex, you want to make sure you're staying in the range of the graph. So it says to pick 5 points, but the way exponential graphs can shoot up so fast, if you select all of them to be positive, you're likely going to run out of range of the graph. So we usually use -2, -1, 0, 1, and 2 for x's. So if I now take this -2, here, and plug it in for x here, what do we get? We get 6 raised to the -2. So if we go to our calculator and we put 6 raised to, how do we raise to on the calculator? How do we raise to? That's this mountain peak right here. It looks like a little mountain peak. That's how we raise to. It's in the rightmost column of the calculator. So let me make sure, do I have I want to double check to make sure the recording is on. Good, it's on. Just want to make sure. So we're going to put a -2 in for x here. And I'm going to go to my calculator and do 6 mountain peak -2. And then at that moment, I'm going to have a -2 in the exponent, and we're going to need to get out of the exponent. How do we get out of the exponent? With the graphing calculator. These arrow keys. You can right arrow out of these arrow keys right here, the right arrow out of that. So I'm going to use this right arrow right there, and that will take me down to the normal line of writing. And now I'm ready to convert that to a fraction. So we convert to a fraction by just doing math, enter. 2 times means enter, enter. So it's math, enter, enter, or you can think of it as math, enter 2 times. So I'm going to do that, math, enter, enter, and I get 1/36. Really hard to come up with that on your own, perhaps, or maybe you can. If you know your properties of exponents, you might be able to, you could switch this to 1/6 squared, which is 1/36. That's another way to do it. So that's what we get for associated with an x of -2. Let's look at an x of -1. Now I'm going to go back to my calculator. This time we are going to take out this 2, and we're going to put in a 1. So 6 raised to the 6 mountain peak, negative bottom row of the calculator. When you select a negative sign, you want to make sure you're selecting the negative in the bottom row of the calculator and not the subtraction sign. That's important. So we have 6 to the negative. I'm going to put in 1. And then I'm going to right arrow out of the exponent and do math, enter, enter. And I get 1/6. So let's put in 1/6 here. 6 looks a little funny, but that's okay. 1/6. Then we're going to put in 0. So I'm going to take out this. I'm going to get the eraser, take this out, take this out, and put in 0. Any number other than 0 to the 0 power is 1. But let's do this on our calculator anyway. Let's put in 6 raised to Mountain Peak 0. Bottom row of calculator, enter, get 1. So this is 1. And next, see, if I were asked a problem on one of these topics that we're talking about now with graphing, this is the kind of written work I would want to see on an exam. So 0, then we're going to put down 1. And 6, we're going to take this 0 out and put in, let me erase that. We're now going to put 1 in for x. So we get 6 to the first, which is just 6. And then lastly, we need 5 x's according to the directions. We're going to put a 2 down here. And if we put 2 in here for x, we would get, here, let me do that. Let's do that. We're putting 2 in for x this time. So we're going to have 6 squared, which means we have 2 6's multiplied together. And that is 6 times 6, which is 36. You could also do it on your calculator. 36 here. So let me just write down what we got. We got 1 over 36, 1 over 6, 1, 6, and 36. Let's go put those in Alex. So that Alex wants exact, they don't accept it if it's rounded. Just keep that in mind. Part of that is because it's important. They want you to graph exactly, so they make sure you understand how to graph. And also it's really, you have to have your computer system set up for rounding. And they don't, with the cognitive scientists and the Alex was created with a National Science Foundation grant. They had cognitive scientists, neuroscientists, mathematicians working on this project. And so they all decided that they would rather see students learn how to do it exactly. So -2 corresponding to -2 is 1 divided by 36. So 1 divided by 36. Next, when x is -1, we got, and I forgot, I got 1 over 36. So we got 1 over 6 for this. So let's do this one. 1, I can use the slash on my keyboard to do this. 1, 6. The next one is, we got a 1. The next one, we got a 6. The next one, we got a 36. Check. Any questions on table for an exponential function? So now let's go and look at those other 2 topics on graphing. I'll go back up into the carousel. And let's take a look at graphing an exponential function and its asymptote, f of x equals b to the x. So really what we were looking at just now is b to the x as well, but we now need to identify the asymptote. So let's start. And just to show you, we saw some, if you were to go to, you can't go very positive here because exponential functions tend to grow fast. And so you don't want to get out of range of 16 or 18 here. So you really do need to pick -2, -1, 0, 1, and 2. So let's look at this problem. Graph the exponential function f of x equal to 8 divided by 3 raised to the x. So we actually have a fraction raised to the x here, unlike what we just saw. Plot 5 points on the graph of the function and also draw the asymptote. Then click on the graph of function button. So once we graph our function, we'll be able to identify where our asymptote is. So let's graph the function. So we're graphing f of x equals 8 divided by 3 raised to the x. So let's go back down to Word here. And this time, let me get another page here, or add a page. Let me get another page, so I'll get a new page for this one. See if I can get up there. So let's take a look at this one. We've got this, we want a t-table here. And this is our x column. This is our f of x column, or our y column, you could call it. Our f of x column, let's call it. F of x equals 8/3 all raised to the x. So we first select -2. And now we plug it in for x up here. So now we want -2 for x. So let's do that on our calculators. So we're going to go parenthesis, 8, division sign, through 3, parenthesis, Mountain Peak, -2, negative bottom row of the calculator. Right arrow out of the exponent to the normal line of writing, and now do math, enter, enter. And I get 9/64. Did anyone else get 9/64? Can somebody confirm that? At 9/64. Anybody confirm that? I would really appreciate if somebody could confirm that for me. Okay, well, let's go on. We're then going to pick -1. And this time we're going to put -1 in here where this 2 is. And we're going to get parenthesis 8 divided by 3 parenthesis Mountain Peak -1. And then we want to math frac that. So that's math key, first column, enter, enter. And I got 3/8. So that's -1 3/8. And it should get a little easier from here on out. The ones with the negative exponents are more challenging. So this time we want to have our x be 0. So if we take out this right here, and we are going to insert 0 there. And if we do 8/3 to the 0, we just go to our calculator, 8 divided by 3, Mountain Peak, 0, and then do enter. We find out that that's just 1, the number 1. So we're going to have to go down here more. And we want 1 here. If I just put 1 in here, we can see what that is. We want to get this eraser, eliminate that. Let's get the purple, the red. We were using red for that. Let's put in a 1 here. If we put a 1 here, it's just 8/3 to the first power, which is just 8/3. So we get 8/3 here. And then we need to look at 2. So let me write down a 2 down here. So now what we are doing is we are taking out this 1, putting in a 2. So we get 8/3 squared. So parenthesis 8 divided by 3 squared. And then we want to convert it to a fraction, and the way we do that, math in the first column, 4th button, and then enter lower right. We do the enter twice. But I forgot to do something, and that gets me from time to time. 8 divided by 3, we're going to do it again. Mountain Peak 2, right arrow out of the exponent. You want to make sure you're right arrowing out of the exponent before you do math enter, enter. And I get 64/9. So 64/9. I'm just going to copy down the ones I haven't copied down so far. So I can now go enter all of those into ALEKS. 0, 1. And then over here, 1 8/3. And then 2 64/9. So let's go put all of these into ALEKS. Any questions on the graphing calculator and how we can use it to help us? I wouldn't have required you all to have a graphing calculator if I didn't think it would help. So I would encourage you all to bring those to class. We're going to start getting into more and more new topics, probably ones that you've never seen before. And so it's going to become more complicated for you. And you want to make sure you're bringing all your resources to class, and that I would encourage all of you to be actively participating in the class. That is doing everything that I'm doing with the calculator. So that's the best way to learn. And you can ask a question if you get stuck while you have me here. That's what I'm here for. And I love to help students in math. So let's go back into ALEKS. I have to think about where I am every step of the way. And we want to click on this tool right here, plot a point anywhere tool. Warning, do not approximate. For example, write 1/3 and not 0.33. Do you not want to approximate here? They want us to put everything in exactly, and they want us to plot 5 points on the graph. So let's take a look here. And I'll point something out in a moment, but let me put in the first one. -2, -2, 9 over 64. 9, 64 over 64. 9 over 64. Checking to make sure it's correct. Correctly entered. Plot point. Next one, -1. 3 divided by 8. 3/8. Just double checking. Plot point. Next one, 0, 1. Plot point. Next one, 1, 8/3. 8/3. Plot point. Last one, 2/64 over, whoops, that gets me from time to time, 2/64/9. I'm going to leave that one there for a minute. If I take 64 and divide it by 9, I get 7.11111. You can see that, and that is a Y value. So I'm already starting to get up to here. So if you were to go and say, instead try 0, 1, 2, 3, 4, I'm not sure it would work for this problem. I think you'd be out of range. So you want to make sure you never get a Y value bigger than 7, a little bit more than 16. So that's why the recommendation is to do -2, -1, 0, 1, and 2 for your X's. So let me plot this point. And now you can see the graph here. Maybe let me make this a little bit bigger so you can see. Now, where would you guess that the asymptote is? Where does it look like this graph is leveling off? Right
on 0.
It's at 0, but it doesn't include 0, correct? Doesn't include it, but it gets ever so close. So that's where we are going to put our asymptote. This graph will never reach 0, but it'll get ever so close. And that's good. Thank you for your comment. I really appreciate it. Shows me that you're thinking, and I'm so happy. And you are on the right path for sure. So I'm going to take my horizontal asymptote. I'm going to go down here and put that horizontal asymptote on the x-axis. Remember, an asymptote is a guideline. Our exponential functions do not cross the horizontal asymptotes. They do not touch their horizontal asymptotes. They do not intersect them at all. They get ever so close. So that graph looks good to me because it looks like, let me click on this again so it doesn't get in our way. It looks like it's going to do this, and it looks exponential in nature. So then I'm going to click on this graph tool. That looks good. Check it and get it correct. So that's the process. And since you can't round, you want to make sure you've got a really smart way to figure out what all of your corresponding Y coordinates are going to be for your t-tables. Any questions on this particular topic? So let's do a progression and do one that's a bit more complicated, and then we'll talk about money. We're going to do some topics on money today. Let's take a look at this one. Graph that exponential function. Notice what's different about this one. It's got a coefficient of -4 out in front. So let me copy down what we need to copy down here, which is really the function f of x equals -4 5/4 all raised to the x. Of course, the -4 is not raised to the x, just the 5/4. And we're going to make a t-table. So we're going to want -2, -1, 0, 1, and 2 for our axis. This is our x column. This is our f of x column. And our f of x is equal to -4 times parenthesis 5. See, didn't want to do that. Just give it a little tail there. Let me try one more time. Sometimes 5s can be a problem when I'm using markup tools. So let's do this. 5 over 4. Raised to the x. So we want -2. Let's do that one first. So this gets a bit more complicated. So we want to put in -2 up here for x. So we are getting a -4 if we put this in our calculator. Negative bottom row, 4, parenthesis, 5, division sign, 4, parenthesis, raised to Mountain Peak, negative bottom row, 2. And then we want to come right arrow out of the exponent and do math, enter, enter. And I got -64. So the graphing techniques that I'm the graphing calculator techniques I'm talking about now aren't just good for this, they're good for other places in the course. So even if you know how to do this by hand, chances are that you're going to find a use for converting to fractions. Having that knowledge on the calculator is helpful. So that's what I got for -2. I got at for an x of -2, I got -64 over 25. Let's do -1. This time, we're going to have -1. We're going to put -1 here. So I'm going to do this. You can, if you're into the graphing calculator, you can save your time, and you want to be into the graphing calculator because it will help you. There's a little, what you can do is this entry up here, it's right above the enter key. The entry will repeat exactly your last entry on the calculator. So it is in blue on my calculator, so I have to use my second button, do second enter to get that. So that's what I'm going to do, second enter. And all I have to do is use the back arrow key to go to that -2 and change it to what I want. And what I want to change it to is a -1. So I want to change that to, type over it with a 1. And then I hit enter. And I now get -16 over 5. Next, we have 0 for x. This time we're going to take out the, oops, I took out the x as well. Didn't mean to do that. And we're going to put in 0 here. So we're going to get, I could do that. Let me do that. I'm going to repeat my entry again. Second enter. And I'm going to have -4, 5/4 raised to the 0 power this time. So I'm going to take out the -1 and replace it by a 0. So delete the negative sign. Delete key is very helpful. The delete key is right here to the side of the arrows keys. So the delete key, I take out, use that to take out the negative sign, and I change that 1. Now I type over it with a 0 and hit enter. I got -4. That makes sense because any number to the 0 power other than 0, it's if you have 0 to the 0 power, it doesn't work. But any other number to the 0 power is 1. And 1 here times -4 is -4. That's how I got that, how I know that's correct. That's a nice double check. Not what I wanted to do. So let me get this erased there. Good. So I was going to draw another line here, and let's look at 1. What happens at 1? Shouldn't be too hard because we're really putting in a 1 for x here. And we want to take this one out, and we want to put a 1 in there. So if we put a 1 in there, we would have a 1 here. It would be just -4 times 5/4 to the 1. 5/4 to the 1 is just 5/4. And then we're just talking about this bit right here. The 4's cancel and we get -5. Now, because I don't want to leave any stone unturned and I want to make sure I'm 100% correct, because this is it's taking me a long time to do this problem. I want to make sure that is correct. So I'm going to repeat my entry on the calculator by doing a second enter, and I'm going to go back with the left arrow key and change that 0 to a 1 just to double check, and I get -5. Lastly, we need one more number. Let's do 2. That's standard. So this time we're going to take out this 1 and put in its place a 2. So this is what we're dealing with now. So I'm going to repeat the entry. So that is second key, enter. And I want to change the 1 there to a 2 and enter. I've got it all set up with converting to a fraction all in one fell swoop. And I get -25/4. -25/4. So does anybody have any questions on the graphing calculator? It's very, very, very useful and will continue to be very useful for you to really understand. We're going to talk about graphing logarithmic functions and rational functions, and we're going to talk about a lot of different topics before the end of the course. So it's really helpful to know how to use the graphing calculator to your advantage. Let me take a look at this for a sec. So -4 times 5/4 squared. Any questions? Anybody have any questions on this? Okay, so let's go put all of these in, and I'm going to have to copy over this sum onto my other paper here. 64 over 25, negative 16 over 5, negative 4, negative 5, and lastly, negative 25 over 4. Let's go back into ALEKS and see what we've got here. So we want to use this tool, this plotting tool, very helpful. First one we're going to plot is negative 2, and then negative 64 divided by slash 25. Negative 2, negative 64 over 25. Plot the point. Next one, negative 1, negative 16 divided by 5. Plot. Next one, 0, negative 4. Plot. Next one, 1, negative 5. Plot. Last one, negative 25, negative 25. So we're, whoops, got to look at the what? You need the 2 first. Negative 2, or sorry, positive 2, negative 25 over 4, divided by 4. Okay, so we're going to have to look at this and try to get a feel for where that asymptote is at. So you can make a guess. Let's make a guess. I'm going to think that this asymptote may be leveling off at negative 2 here. So let me try that. So I'm going to say it's there. I'm going to say it's there. And now let's see what happens if we click on this. That doesn't look right, does it? I'm wondering if I did one of my numbers wrong. So let me just take a look and redo. Let me go look at my numbers for a moment. So I want to undo what's here. I think maybe I did one of them wrong or something like that. And certainly didn't mean to do that. So let's see. I suspect I have an idea of which one it is. So negative 4 times 5 divided by 4. Negative 4 times 5 divided by 4 raised to the negative 2. Raised to the negative 2. And then math bracket, negative 64 over 25. Does anybody if anybody knows what I did, that would be helpful. I'm not sure exactly. Let's just see if this, because I checked the one I thought it might be, but I was not correct. If I put my horizontal asymptote here, I'm just wondering how I would delete this one right here. There. Oh, I wonder if I put my horizontal asymptote here, what would happen? I'm not sure that's going to work, but let's try it anyway. I don't know all of ALEKS's little idiosyncrasies because they have so many. What happens if I graph it now? Will it do it? Oh, it does. There it is. It wasn't anything I did wrong with the points. It was just harder to tell where to do it. Harder to tell. Kind of throw me for a loop, check. And what happened? We got it correct. So let that be a lesson to all of us. I've never seen one like that before, by the way. So that is correct. So just, I can't promise you that every one of these is going to be on the X, every one of these horizontal asymptotes is going to be on the X-axis. I can't promise you that because I can't see all the ALEKS problems. Any questions on this, on the graphing? Any questions at all on the graphing? So now what I want to talk about is money. We want to talk about compound interest and continuous compound interest. So I marked up some of these problems already, but I think I should, I don't know how long it's going to take me to erase it, and I'm sorry. Let me erase some of these so we can do this. I had a class right before this. They don't have that nice, let me think about what I'm doing here because I could, yes. Do you have a question? Do you have a question? Yes?
Could we do it together? Can you hear me?
Yes, I can.
Yeah, I think. Can you hear me?
It's a little, it's a little garbled or something, but I can try. Courtney, is that you? Have a question?
It is. Can you hear me?
You could ask her to type it in the chat.
Yeah, okay. I think I can hear her better now. Courtney, go ahead.
I was gonna ask you if you could, like, if we could do it together. The problem that you're erasing.
So when you say do it together, do you mean going into ALEKS to do it together, or what do you mean, Courtney?
I don't know. Like, I want to follow, like, you doing it.
Right. I'm going to, but when I go into ALEKS to get a problem, it's not going to be the same problem that I got for my class that was right before yours. Do you see what I'm saying? Which is why I'm erasing it.
Oh, okay.
Okay. That's exactly where I'm going with this. So that's why I'm trying to erase this really fast, so not to take up too much time. That was my thought on this anyway. So we've got some more down here. Let's go look at this. Okay, I think I've got another problem, but I'll erase that later. I'm getting a little tired of erasing. Okay, so, and I know we all would want to talk about this. So what we're talking about now is what we call compound interest. Compound interest is really what banks and financial institutions use. There used to be what we called simple interest, but we don't really use that anymore. So compound interest, what that really means is if you put some money in the bank, say $100 in the bank, and you leave it there, you don't make any withdrawals, you don't add any more than money to it or anything like that. And let's say the interest rate is 10% compounded semi-annually. So you put that initial $100 in the bank, and the interest rate is 10%. And if you were to convert that to decimal, it would be 0.10. Or we could just use 10%. It's pretty easy to use. Compounded semi-annually, that means twice a year, every 6 months. So at the end of 6 months, we have $100 in there, and let's say, so at the annual interest rate is 10%. So that means at the end of 6 months, you would get paid 5% on the $100. That makes sense. So you would then have $105. And then at the next 6 month mark, which would be at the 1 year mark, you would get paid 5% on top of that. So I'd have to do the numbers, but we'd get 105 times 0.05. So that would be 105 times 0.05. That would be $5.25 added to that at the 6 month mark, and we would have plus 105. And you don't really need to know this. You'd have a total of $110.25. Why I'm saying this is because what happens with compound interest is you're really, the first time they gave you interest, they took that first amount, which was $105. And then the next time they give you interest is they're giving you interest on top of the 105. They're paying interest on the $105 now. So you're getting, in a sense, interest upon interest. And it didn't used to always be like that, you know, and not all institutions used to do that because they don't want to pay, they want to pay as little interest as possible. But lots of, you know, banks use compound interest. When we're paying on our mortgages, we're probably paying compound interest and so forth on our mortgages as well. So I just wanted to give you a little idea of why we are talking about compound interest. It's very useful just to kind of give you an inkling of what goes on in terms of compound interest. So yes, I definitely want to do a problem here. So let's go and get one out of Alex and write it down. So let me find one. Let's do this one. Find the final amount in a word problem on compound interest. And we will be seeing compound interest a few objectives from now again. It's not loading for me. More practice. I didn't think it was loading for me, so I clicked on it again. So here's the problem, what we want to do. Lucy borrowed $8,000. So I'm writing this down at a rate of 18.5%. Compounded semi-annually. Assuming she makes no payments, how much will she owe after 6 years? That's the question. So just give you one more moment if you're trying to copy this down, the problem that we're going to do. So I'm going to go back down and do this problem. And I wanted to have some other information here to do this problem. We can try to make this a little bigger. Yeah, I don't remember how to make this. I know there's a way to do this, but I think we're good here. So we have this problem that we want to do. we want to find the amount that she will owe after 6 years. We want to find that final amount here. So what we've got going on here is the final amount A owed. Yeah, I wish I knew how to make this a little bit bigger. Can you all see this pretty well or no? Do you want me to try to figure out how to make this bigger? Yes or no? Can you see what I'm talking about here? Don't be shy.
I can see it.
Okay, good. Good. So I want to take a look at this and let's read through this just to get some idea of what we're given here. This I just pulled right out of the explain page in ALEKS, the explanation. I thought this would be helpful so we could do the problem that we just wrote down. The final amount A owed is given by the compound interest formula. A equals P, parenthesis, 1 plus R over N raised to the NT power. So that N appears twice. So what do these variables stand for? This P right here is, and these numbers aren't correct for this problem. This is just an example that I pulled so that I could so we could see what these variables stand for. So P is the principal or the deposit, or how much money you invest or borrow. This is the amount, P is the amount of money that you invest or borrow. So like in our problem, the person is borrowing $8,000. That would go in for the P. It's the amount you deposit or borrow. So you might want to write that down. So now this is a 1 plus R is the interest rate in decimal. You can either take off the percent sign and move the decimal point, 2 places to the right, or you can take, since percent means parts per 100, you can actually take the 12.5 in this case and divide by 100, and you will get 0.125. And we'll do it that way when we do our problem that we just copied down. And the N is the number of times interest is compounded each year. So if in the case of our problem, semi-annually, that's twice a year. And you can see this little graph down here, or this little chart here, semi-annually means twice a year. Number of times interest is compounded each year, 2 times. And then this T is the total time in years. And just some of the terms you might see: annually, semi-annually, quarterly, monthly, weekly. In each case, this little table gives you how many times interest is compounded each year. Annually, once. Semi-annually, twice. Quarterly, 4. Monthly, 12. Weekly, 52 times. There may be some others. And how I got this little chart here, I just clicked on more right here. I just clicked on more here. So if you don't, and I don't expect you to know all of these. So if you need to, click on more to see. So why are we looking at these with respect to exponential functions? Because in the next few objectives, we are going to get to a place where we're going to look at being able to find the time and that's going to be a variable in the exponent. So we're building ourselves up to that. Right now, all we're finding is A. All we're finding is the final amount. So I'm trying to take you through a series of progressions so that it's easier for you. So what do we have for our particular problem? So we've got A is the unknown. So we want to find A. So let me put that here. A equals, what's our P? P is the principal deposit, or how much is borrowed. In our problem, the person borrowed $8,000. So $8,000 and then we have a parenthesis, and then we have the number 1, and then a plus sign. Maybe let me put a little bit more on there, just emphasize that it's a plus sign. And then we've got R. R is our interest rate in decimal. Now in our problem, not this one, this is just to let us know what the variables stand for. In our problem, it's 18.5%. So my preferred way that I like to do it is I like to take the 18.5, go to my, and divide it by 100. Since per that percent sign, I'm going to take it off because I know it makes it, or I know it means parts per 100. So parts per 100, we want 18.5 parts per 100. And I'm going to go find out what that is on my calculator. 18.5 divided by 100. 18.5 divided by 100.
Wouldn't it be 0.185?
It's actually 0.185. This is 18.5 here. Did you include the point in it? It may be a little small.
Yes, I did.
Do you see? If you take 18.5, so what we were given, just to be clear, is we were given 18.5 in the problem percent. So one way to do this problem is to take the and let me put on the answer here before I get too far ahead of leaving you to, I got this whoops. Okay, so I guess I'm into the header, so let me see if I can get back out of this. Okay, I got 0.185 for an answer here before we go too far. I don't want two things going on at one time really, or two thoughts. Let me just finish up here. I got 0.1885 on my calculator. And this is a point there. Okay? So that's what you would want to use, but and this percent just means parts per 100. So I took this 18.5, copied it over. This percent means parts per 100. This is per, think of that as per, and then put 100 in the denominator every time you want to do this. The other alternative is to move this decimal point, take off the percent sign, move this 2 places to the left. 1, 2, you're still going to get 0.185. I just prefer to do it this way. It's my own personal opinion. That works for me. I feel I'm more accurate, but you can do it either way. So our interest rate here is the way that we need to include it in this formula is 0.185 no matter how you do it. So I'm going to put the 0.185 up here. Just want to make 0.185. Up here. It went in for R. It went in for R in the formula over here. Divided by N. Now this N occurs here and it occurs up in the exponent. It occurs twice. N is the number of times interest is compounded each year. We were given that our interest is compounded semi-annually. Semi-annually means twice. So I'm going to put this in here. Make sure I get on the draw tool there. I'm going to put 2 down here. And I'm also going to put 2 up here because it appears twice in the exponent. It appears twice. That N appears up here as well. Up here. And then times T. T is the number of years. Our question in the problem is how much is owed after 6 years. So T is 6. So I'm going to put 6 up here. And that's what we have to figure out. What is that equal to? And then we're going to round to the nearest cent. So I'm going to go to the calculator. 8,000 times 1, or 8,000 parenthesis. Not 8,000 times, but 8,000 parenthesis. 1 plus 0.185 division 2 parenthesis Mountain Peak. That's how we're going to get these numbers in. That Mountain Peak in the rightmost column, it looks like a little tiny mountain peak right above the division key, Mountain Peak. And then 2 times 6. Enter. I get the following. I think I'm okay here with this. So we've got 23. Trying to make a dollar sign and with my trackpad. Dollar sign, 23,000. $128. $23,128.49. The next digit is a 2, so it's just 0.49. We want to 0.49. Any questions on this as to maybe why you didn't get the correct same answer I did? I mean, maybe I made a mistake. You know, did anybody get that same answer? Is anybody trying along? It's probably, I would encourage you to try the problems along with me, because I think that would not only, they might give you confidence. And I think some of math is being confident. Any questions on that particular problem? So the answer I got, $23,128.49. So I'm going to go and enter that into Alex. Hopefully Alex will have saved my spot. 23. They like commas. So I'm going to 128.49. Check. Any question on a particular topic? Finding the final amount in a word problem on compound interest. I want to reread this problem for a moment to make a point. And I think you'll see my point after we look at the next problem, but I want to reread this problem. Lucy borrowed $8,000 at a rate of 18.5%. As we read this problem, let's look for the word continuously and see if it appears. Lucy borrowed $8,000 at a rate of 18.5% compounded semi-annually. I'm not seeing the word continuously. Assuming she makes no payments, how much will she owe after 6 years? Still not seeing the word continuously. And do not round any intermediate computations. We don't need to read that. The reason why I'm reading this to you is because I want to go look at another compound interest problem. Here's the one I want to look at, and I want to read to you, I want to show you. In this problem, you see the word continuously. That's how you know that you don't use the formula that we just used. You use the other formula. That's how you're going to be able to decide which formula to use, whether it has the word continuously or not. So let's go back down here to Word for a moment. And let's go back up here. I guess I'm going to have to do a little bit of erasing here real quick. Let me see what, okay, it's 4% there. So I'll just erase, get this eraser and do it as fast as I can. Erase, erase. This is trying to help me erase faster. See, I learn something new every day with what I'm going to erase, erase. There might even be a faster way to do this. I was hoping I would get some more than that. I'm not going to worry about that. It's not so small. I don't think it'll really cause a problem. Okay. Now, we are talking about now continuous compound interest. That means you're going to see a word continuously in the problem or continuous in the problem. So that's what that means. Now these other variables, A, P, E is a number. E is a number like pi, non-terminating, non-repeating, and I will need to show you how to put that E in your calculator to be able to do this problem. Raised to the RT. It's called the PERT formula. PERT used to be a shampoo a long time ago, probably before many of you were born. So that's what I want to say. So, but the A, the P, the R, and the T mean exactly the same as in the previous problem we looked at when we talked about compounded semiannually. So they mean exactly the same. So that you don't need to relearn, you don't need to learn twice what those variables stand for. So let's see what kind of problem Alex gave us. Let's go back up to Alex and write down what we need to write down. So we have an initial amount of $3,600 is invested in an account. I'm going to write down the interest rate. 4% per year, 4% compounded continuously. Well, we've selected the right formula, so we don't need to write that down. Assuming that no withdrawals are made, find the amount in the account after 5 years, at 5 years, at the 5-year mark is what they really mean. So I'm writing that down. Do not round any intermediate computations and round your answer to the nearest cent. So we're almost done. So this shouldn't take us too long. Let's go back in right down here and write this problem out. So we know we're looking for A in this problem, in this capital A here. Down later on in the next couple of weeks, we're going to be learning how to find T, and it's going to involve a logarithm. So we're going to make that progression. So we want to know what A is. So A equals P. P is the amount at time 0, the initial amount, the principal amount. So the initial amount we are told is 3,600. So that's our P. And then E is just a number, this very special number, raised to the R. R is our interest rate. So we were told that our interest rate in this problem is 4%. Trying to make a percent sign and not working for me too well. Let's try again. I'll do it like I did it last time. Something like this, 4%. Use your imagination. So this percent sign is, we can take it off, take the decimal point, move it 2 places to the left, or we can just take the 4 and divide it by 100, which is what I prefer to do. If I do that on my calculator, 4 divided by 100, I get 0.04. And if you took your decimal point, took this, remove this percent sign, the decimal point would be here, you'd move it once, get 0.4, move it again, get 0.04. So it works really nice, no matter which way you work it. I just find I'm more accurate doing it this way. So I'm going to put the 0.04 up here. And then times T. T is the number of years. They said at the 5-year mark, so that would be 5. Okay, so that's what we've got to enter into our calculators. So let's talk about E a little bit. E is in the first column here. Well, E to the X is. So let's look for, go up to the third button from the bottom. That's the ln. It's a natural logarithm. It's actually the inverse of e to a particular power. It's actually the ln and the e act like the the exponential function and the natural logarithm functions are inverses of each other. That's why they're paired together like this. But the e to the x is above the ln key down here. Okay, so that's above a key, so we have to use the second button and then click on the ln button E when we do this problem. So keep that in mind. And now let's go ahead and do this. So I'm just going to enter 3,600 on in my calculator. E, so E, where do we get our E again? We go back here. It is, we want E to the X. It's right here. It's in blue, so I have to go get my second key. So it's second ln. I have to do the second key first, and then the ln. So second key, second button, and then ln. And I get E to a box. Well, in that box is where we're going to put the 0.04 times 5. 0.04 times 5. Enter. I got $4,397.04, but the next digit is a 9, so I have to bump that 4 to a 5. So this is what I got. 4, comma, 397 point 0.05. Any questions on that? So before I let you go, let me just go quickly into Alex and enter that. I'm afraid it's gonna go away. 4, comma, 397.005, and then let me just double check that. $4,397.05. Any questions on that? Anybody have any questions for me? So this is the ending time of our class. If you have any specific questions, you're welcome to stay around and you know, I can go over something with you that you don't understand. I'd be more than happy to do that. So let me unshare my screen and let me make sure I'm taking attendance before you all leave. Feel free to leave now. If you want to stick around, I can answer questions, and take care and have a good weekend, and I'll see you on Tuesday of next week. Bye for now.
Thank you.
You're welcome. Courtney, did that help?
Yeah, I tend to do it better whenever like I'm doing it with, because it
Oh, that's good.
challenges me. I have a question though. I got it. I had received an email from you, or like a message on Canvas.
There are
Or
other
I don't know
people.
if everybody got it. Huh?
Yeah, there are other people in here right now, and I'm not sure if they're.
Okay.
So it sounds like that we need to have a private conversation, to be honest with you. Or what was, yeah, because I'm not sure. Let me just,
Yeah, I'm not sure either.
yeah. Brian, are you still here? Isabel, are you here? Can you hear me? I'm not sure there's a way to have them get out. Courtney, can you just get back in a few, what I'm going to do is I'm going to end this meeting, but I'm going to open one up with really fast so that if you just click on the same link that you usually do, you'll get in. Do you see what I'm saying?
Yeah.
Okay, so let's do that instead.
Okay.
Brian and Isabel, are you still here? I think they just didn't log out yet. So I'm going to, yeah,